In this video, we're going to look at how we can simplify radicals and how we can change from rational exponent form to radical exponent form and be able to interchange at any time. So look at the conversion from both radical to rational and be able to simplify that. Simplify the radical expressions. So I want to look at this example, and particularly here where we see that we start with b to the n and it equals a. So in this algebraic equation, I would like to solve for b. Well, since I'm raising n to a power, I could use the power rule and raise it to the 1 divided by n power. Well, I have to do that to both sides. So I apply the same power rule operation to both, and what I get when I get n times 1 divided by n and a to the 1 divided by n, what happens here is I get n divided by n and it goes to 1. And so I get a to the 1 divided by n power equals b to the first. And this can also be written as a as the radicand and n as the root or the index. So both of these equal the same, b to the first power. Here's your rational form and here's your radical form. And that's what this example discusses. It just shows how both are equivalent. And just remember that n represents the root and the numerator represents the power. So if we take these, I got the square root of 36, which we know we can evaluate that to 6, and we know we can take the square root of 64 and evaluate that to 8. And the square root of 20 we know is going to be somewhere between 4 and 5. And should be 4 and 47 hundredths with a continuation with no pattern. So if I want the rational form, this would be 36 to the 1/2 power, because the understood index or the root is power of 2. So that's part A. Part B would be 64 to the 1/2 power, and part C would be 20 to the 1/2 power. So a couple of ways we can, just to make sure that we're on the same page of how to calculate that. If you want to calculate the square root of 20, you could type second and then the x squared button, because I want to utilize the radical. So second x squared, type in 20, hit enter, and it gives you your value. That's the radical form. Or if you want to use the rational form, you would hit the open parentheses, 20, close it, raise it to 1 divided by 2, close it, hit enter. You should see the same result. So look at the next. We're looking at our root. Notice our root would be the third root. So we would say 64 to the 1/3 power would be the rational form for part A. For part B, we would have 27 to the 1/3 power, and C, we would have negative 64 to the 1/3 power. So if I want to calculate that, I would say open parentheses, 64, close it, raise it to the 1 divided by 3, or the 1/3 power, and we get 4. And if I take 27 and raise it to the 1 divided by 3 power, I should get 3. And then the last one was negative 64 raised to the 1/3 power. So I have open parentheses, negative 64 raised to the 1/3 power. And I would get negative 4. So this just means that 4 times 4 times 4 is equal to 64. And 64 is and the third root of 64 is 4. And 3 to the 3rd power is 27. So therefore the third root of 27 is 3. And negative 4 raised to the 3rd power would give us negative 64. And the third root of negative 64 is negative 4. And our example here, so we have numbers, for instance, for 36, I am still taking the square root or the second root of 36, and I want to cube the result. Part B, I have 8, and I'm raising it to the third, or excuse me, take the third root, and I'm going to raise 8 to the 3rd power. And then part C, I'm going to take the third root of negative 27 and raise it to the 5th power. So those would all be the radical form. And if you want to evaluate it, you would take 36, just as you see here. So 36 to the 3/2 power. So I type 36 in parentheses, raise it to the 3/2 power, and I'm going to get 216. And then we'll look at one more. We'll look at 8 to the 2/3 power, and let's make sure that that's written correctly with a power of 2. And we can do this one. We could say the cube root of 8 would be 2, and 2 to the 2nd power would be 4. So if we were going to evaluate the first one, it would be 216. The second one would be 4. And the third one is we would take negative 27 and raise it to the 5 divided by 3, or the 5/3 power, and we would get negative 243. So I want the radical form. That's my radical form here. Now let's look at simplifying these radicals. So negative 2 times the square root of 32. The intent is to find 2 factors and one that's a perfect square. And so I'm creating my factor trees. And what times what would give me 32, and I would be part of my perfect square family, and 16 is a perfect square, and 2 is prime. If I can get a perfect square and a prime number, I know I'm simplified as much as I can. So what is the square root of 16? That would be 4 all times the square root of 2. So then I would simplify this one, and this would become negative 8 times the square root of 2. And that is part A. So part B is negative 7 times the square root of 52. And the square root of 52, I'm looking for 2 factors. And that would be 4 and 13. 13 is prime. Square root of 4 will be a perfect square. So it becomes 2. So I get negative 14 times the square root of 13 is the simplified form of this. Let's look at the next one. So square root of 245, and if you are having trouble thinking about, okay, well, what are those factors? You can use your calculator and go to y equal and type in 245 divided by x and go to second graph. And what you're looking for are factors, and I'll get into the positives. You're looking for factors. The x and the y are all factors of 245. But you would like to find your largest perfect square, and you want to look for both of them, not just the left-hand column. For instance, number 5 here. 5 is prime, so 5 times 49 is 245. So 49 is a perfect square and 5 is prime, so that is what it would simplify to be. So square root of 49 and 5. Square root of 49 is 7. So you get 7 times the square root of 45 is what the square root of 245 is simplified. Part B, I want the square root of 828. Again, it's a large number. I don't want you worried about trying to find those factors. Let the calculator generate that for you, and then it's what you're looking for. So 828 divided by x and go second graph. And as I said before, you're looking for factors, and 276 is not a perfect square, and neither is 204 is. 207 needs to be simplified some more, so I want to keep searching. 9 and 92, I can still simplify 92, which means I don't have the largest perfect square. 16 is a perfect square, but 51 and 75 hundredths is a decimal, so I want to keep going to the next one, which would be 25. And there's a decimal, so I want to keep going to the next one, which would be 6 times 6, or 36. And there it is, 36 and 23, and 23 is a prime number. So this one would be 36 and 23, and the square root of 36 becomes 6. And the square root of 23 I'm going to bring down as part of the expression, and that's as far as I can go. Same with a square root of 1053, and 3 times the square root of 847. So 1053 is 1053 divided by x. And remember, if you want to start your table at 0, you can go second window, and it says table set. So I'm going to start at 0 and then go back to second graph, and it should be right there. So 1053. I'm looking for, I see 9 and 117. I see 13 and 81. 13 is a prime number, and I know 81 is a perfect square. So it's going to be 13 and 81. So square root of 13 and the square root of 81. And the square root of 81 is 9. So I'm going to rewrite this as 9 times the square root of 13. That's our notation as we put our integer factor to the left and our radical to the right. So the next one will be 847. So type 847 divided by x. And I'm going to make my table set at 0, second graph, and 847. So I'm looking for a perfect square. factors, and there it is, 7 and 121. 121 is 11 squared, and 7 is prime. So I do have a 3 factor out here already, and this will be 121 and 7. So this will become 3 square root of 121. The principal square root would be 11 and times the square root of 3. So this will be 33 times the square root of 7. So again, just to recap, what are you looking for when you're trying to simplify your radicals? Is if it's a larger number, you can type it into your calculator, the number divided by x into the y equal, go to second graph to check your table, and you're looking for one factor to be a perfect square, and if the other factor is prime, that's fantastic. It may not always be that way, but square root of 121 was the perfect square here, and 7, square root of 7, the radicand was prime, so we didn't have to simplify it anymore. And don't forget this factor out here. You had a factor of 3, and so that had to continue to be multiplied all the way through. So 5 times the square root of 27 for part A. 27 is a smaller number, so it would be the square root of 9, square root of 3. So it'll be 5 times 3 times the square root of 3, or 15 times the square root of 3. And then part B, we've got 6 times the square root of 80. And for 80 should be 16 and 5. And so 5's prime, so 16, square root of 16 is going to be 4, principal square root, and so 6 times 4, I get 24 times 5. Don't make the mistake and try to simplify this 4. This 4 is a whole number. You're not taking the square root of this 4, so you're multiplying the 6 times 4 to get 24. And you know you're finished when you cannot simplify the radicand any longer. So for the check, I want to change number 1, the 5th root of 5 to the 2nd power to a rational. So this would transform or be converted into 5 to the 2/5 power. 5 meaning the root, which is the root here, 2 being the power. And if you want to evaluate that, you type 5 to the 2/5 power. So 5, raise it to the 2 divided by 5 power, hit enter, and you get about 1 and 9/10. So if you evaluate it, you get about 1 and 9/10. And that's number 1. Number 2, 216 to the 5/3 power in radical form. 216 would be the radical. The 3 is your root, and the 5 is your power. So if you're going to evaluate this one, 216 to the 5/3 power, type in 216, raise it to the 5 divided by 3 power, and you get 7,776. And then finally, the last 2, so number 3 would be 252. And I want to simplify that, so 252, and go to y equal. Type 252 divided by x, then go to second graph, And 252, we're looking for factors. So far, 4 and 63. Let's see if we've got a higher one. 9 and 28, getting closer. 16 and a decimal, so I know square root of 16 is not going to work. If I keep going, and I don't see, there it is, 36 and 7. So square root of 36 and the square root of 7. Seven's prime, 36 is a whole number, so you'd get 6. 6 times the square root of 7. And then part B was 3 times the square root of 44. And 44 has the square root of 4 times the square root of 11 times 3. So 3 times the square root of 4 is 2 times the square root of 11. And so you get 6 times the square root of 11.